Should I just put this here or like this? Okay. So I've prepared this talk a bit. I mean, it's like a summary of my previous talks. I will briefly introduce also myself, but I guess it's helpful beforehand to ask like what your interests are, why you're here, kind of thing. So who of you is like actually interested in Datalog or in distributed Datalog? Okay, that's not bad. Distributed systems. Probably everybody has to deal with them. So that's part of my motivation. You are, I guess, all doing Clojure script, like getting there. Okay. Cool. Okay, so I will just start, and then I guess like I figure out the American style of presentations is sometimes rather interrupt. So not do the full presentation, ask questions at the end, but have a more interactive style. Okay. That's at least in UBC. It seems to be common to do it that way. So feel free to ask me at any point in between, and we can go into this. And in fact, if it gets too long, I'm not exactly sure, or you are more interested in going into some Datalog examples or something like that, we can also adapt the presentation. So if something arises, I'm flexible in that sense, because we're a very small group, and that's actually good to be very interactive. Okay, so first I will talk briefly about me a little bit, and then we go into more detail. So I didn't know what picture to start, but I thought I take this one because this is the city that I come from. It's very like monstrous in some sense. So this is an industrial city in Germany, but it's a city where the bicycle has been invented, the car has been invented, Mercedes-Benz comes from there. This is not how my home looks like, but it's not far away, so it's a fairly industrial place and very practical, and people are very pragmatic, high migration background. It's like a very, in that sense, working class and vibrant place. But I've actually studied here, which is arguably, that's like 25 kilometers away. That's arguably, you could see this power plant somewhere in the background, but this is the castle of Heidelberg. Heidelberg is arguably the most beautiful city in Germany. So if you ever get there, that's like recommendation, go to the castle, look into the valley of the Rhine. It's actually the Neckar. So I studied philosophy there and computer science until last year. And then I came here to do my PhD. So I have like a pragmatic industrial tinkering background, but I also have, you will see that in the talk, and I'm thinking about trying to think about things a little bit systematically, which one can argue whether it's practically immediately useful, but I think like distributed systems raise some fundamental questions, and I think this relates to that. So we can talk about that afterwards, or beer or something. I don't know. It's not super relevant for the technical stuff, but just to give you a background. So I have done a lot of work on the replicative libraries, which you might have seen or might not have seen, and they have some useful bits in them. I have co-founded a Clojure consultancy with a friend in Heidelberg last year. We have done some work, and we start to get some clients on our distributed database stack, which is awesome because you get paid to do work that you like to do, which is really nice. Hopefully, I mean, we already have clients, but hopefully we like to do the work. But actually what I'm mostly doing right now, and it's like more than a full-time job, is doing a PhD at UBC, which is an amazing place. It's really cool, but it's also a shit ton of work. Okay, good. So the outline of my talk is, first I want to talk a little bit of the motivation, why I reason about a language for distributed systems, why might Datalog be interesting. Then I will talk a little bit about the technical background of the replicative libraries, because that's what I know a lot about and where I can actually, what I've kind of contributed. Then I will talk a little bit about Datalog, like give you an example, explain it a little bit. I think most of you already know that. We can, of course, do more technical things, but I'm not sure what exactly is whether you want to know how the query engine exactly works or something like this. I think that's like maybe a little bit too technical. The purpose of the language is actually to abstract over this. Then I will talk about datahike. That will be a little bit more technical, which is like the combination of datascript and a durable index. So you can use it like datomic, but it's actually open source and it's kind of easier to plug in. It's also not nearly as powerful, obviously. Then I will talk a little bit about some brainstorming big picture ideas, which more relate to the philosophical ideas, which is Datopia, which I'm currently working on with a friend and blends into this a little bit. And finally, some outlook of what Datalog could be and what the Clojure ecosystem could do with that beyond that and what we have in mind. So first of all, for me personally, when I started programming, I did Java. First I did C++, then I did Java, and I had this at the university. I didn't have Python, so maybe if I would have had Python, I would have been more confused and thought like Clojure is actually not that beneficial. But fortunately, I have had Java, and then it was really great to look at Clojure immediately. So I found it a very strong relief mentally. It's just much, I mean, people think functional programming is hard. I think that's wrong. I mean, even Haskell, I would say, is easier to learn than Java, despite the fact that people then do crazy things with it. But in some sense, having a very functional language that you can pick out pieces of it, reason about single functions, describe what you want to do, and then basically separate your concerns and your state changes is a big deal. It requires a mind shift, but I think it's a relief. So yeah, the main part, I think Rich Hickey there is right. I mean, because we have all these type systems and I have friends at UBC, and like you can do dependent types and you can do refinement types and you can do a lot of things in addition in functional programming. But actually the big simple idea is factor your state from the actual logic of your computations. That's like the first step and maybe the biggest step that you can do to help yourself. And the other things are more arguably are some kind of trade-offs. How much logic do you want to incorporate in your language? How many invariants do you want to enforce? Datalog in some sense is one example of this, which is like describing logical invariants. But the question immediately arose for me because I wanted to build, like I played with BitTorrent integration into the browser and had like these ideas if I want to actually build kind of distributed social infrastructure. So that's all nice if you play on a REPL and you have your local thing. But once you start to think about a distributed system again, then actually what you have is something like this. So you build your server and your machine in Clojure, and everything is nice and fine. You have maybe one state atom or one object that managed state well for you, but now you need to glue it together. And these are in fact objects again. So you have then even remote procedure calls, so you cannot debug easily because there are no stack traces over machines. Things start to become messy. And that's actually industry standard right now because everybody's doing microservices because it allows them to incrementally onboard people, do technology choices specifically, integrate things. But it's actually a very ad hoc thing. And it's very unsatisfying if you want to actually get rid of the complexity, I would say. So I found this kind of difficult. And I mean, I'm not the only one who had problems with this. Actually, Clojure was developed to implement datomic, Rich Hickey at one point said. And I think datomic is like Rich Hickey's answer for distributed systems programming and building a distributed system. So let me briefly explain this sketchy, graphic, cartoonish thing. So again, you have the same three hosts that you have basically here, but instead of having them talk to each other directly and changing state all the time, you basically talk to a serializer, which is called a transactor in a database, which takes all your changes, applies them to the system, and then you basically, that's why I have separated it, the read operations in the notion of datomic are deliberately separated from the notion, so they don't run in the transactor of the database. You can actually run them on the host, and you only dereference your database to do your read operations. That makes sense. I don't know, who of you has done anything with datomic? Probably. Okay. So the idea is basically if you can do this, then your query engine runs in all of these nodes, and it's much more flexible, and you can like many interesting properties pop out of this. But it's just, if you try to think Clojure and persistent data, if you think the whole world in persistent data structures, you would basically arrive at an idea like that, kind of, because try to make your database a persistent data structure, and then something like this happens. So it's a functional, Datomic is like a functional distributed database, functional in the sense that it's immutable and you get a new value and you can reason about this in this sense. It is durable. That's a difference to the Clojure in memory semantics. It's again persistent, like the persistent data structures of Clojure, so it composes well with them. Actually, on the other hand, also implementing a database like this in Clojure is very convenient because your memory semantics fit your durable data structure, so you don't have to worry about race conditions or whatever in memory. Everything is basically persistent. That makes implementing datascript and datahike fairly convenient, I would say, compared to other languages. And it's distributed, so it's possible to replicate the trees that are behind the indices between your peers. So actually what you've seen before, oops, that's not how it works. Ooh, it's laggy. Okay. These read operations happen on these hosts, and the indices are replicated there. So you can actually read locally in your machine on this database snapshot. But we will see this also later again. So this makes it, and then there's one question, like you can do this, of course, for an index, but what do you get out of it? Like a sorted set, it's like a little bit low level maybe. So what language do you pick for the system? And then interestingly, Richiki has picked Datalog, which makes a lot of sense once you learn what Datalog is. So Datalog is basically, and I will also talk about this later, Datalog is basically a little bit like SQL. So it's like more convenient, lower language, constraint language, more abstract than just talking about the index. This makes it very read-scalable. Datomic is deployable on AWS. You can call in your Lambda functions, and they actually exploit this fact a lot. I would often make the point to friends like this is, or even like in a distributed systems lecture at UBC, I try to make people realize this is the most read-scalable system on AWS because it cannot be more read scalable than this. And if you start to do different things and don't have persistent data structures, what can you do? You have to coordinate, and it can only be slower. So, okay, but I think the most important part, even like these are the technical details, but what I realized like 2 weeks ago when we talked about MapReduce in a distributed systems lecture, and Google decided to, in 2004, to ignore all the best knowledge of the SQL community, and they actually wrote like responses to the MapReduce paper, like, what are you doing? This is all nonsense. This is way too low level. It doesn't make sense. Like all the database, you don't have indices, you just do batch processing. Yeah, it's not actually a very reasonable thing, but the insight was that the problem is you cannot decompose a SQL database and adapt it to your scalability needs. These things are from the 80s and very monolithic. I mean, you can download MySQL or PostgreSQL and so on, but if you want to go in there and change it a little bit or get access to the index, that's extremely hard because everything is mutable and glued together. You cannot just go in there and dereference the index while the database is running, because then you don't get a consistent snapshot. So you have all kinds of problems. And Datomic, if you look at the talks of Richiki, is actually built in this way that it's like it has these persistent data structures. It can use a key value store. It's actually built on top of other data stores, and it can be replicated. It's very. I think even the talk is called something like this, decomposing the database. Something I would have to look it up, or it's exactly. But yeah, the only problem is for me is. This is nice for Cognitect because they have the source code. I don't have the source code. And initially I thought like, well, maybe they are right about this. They have much more experience. I'm just a student. And I like open source a lot. And I think it's very important to have access to your database, but it's still so much better. I use it and I recommend it to clients and people that I work with and try to push it. But it's pretty hard to push a closed source database in many, I mean, it was very hard to get it into applications because it's closed source. And yeah, another problem I will try to move on the road of distributed systems is that's only addressing backend needs. So it's a pure JVM system. It's conceptualized for scalable app backend. It's not answering how you do the full distributed systems, because if you look at your distributed systems again, then you might now have solved the problem in here, but actually the difficult part, if you take like React and you start to build your client app and you do this as well, how do you glue this together? Like in most of the logic and the questions, like what interface do you use? Is this REST? Is this GraphQL? What kind of thing do you do? How is the granularity of your endpoints? how do you access them in the right pattern? How do you access control? I mean, most of the problems is actually just crossing this boundary, I would say, or at least a big part. It is annoying. It's very redundant. I mean, maybe it needs, some parts of it need to be redundant if these services are different all the time and are like custom industry specific things, then there's little you can do. But imagine for now, this for the sake of this talk, you could try to make this homogeneous and try to figure out how to build a system for this. So the question is, how do you connect this? And then there was a very nice blog post that tried to summarize this from Nikita, the author of Datascript, who actually said like, okay, by the way, I've written this Datalog implementation for the clients. So we can now also have Datalog on these endpoints. And he had this idea of, we can actually stream from the transactor the changes that happen to the database also in our front ends. So these are just like small changes to the index. If you know which queries these clients are interested in, you can basically pattern match on the changes and just like get small deltas out of them and update all your clients. And you don't have to like reason about all these queries just to copy a little bit of data and do this. Note one thing here, I've just drawn the arrows in this direction. So while we have a way to talk to the transactor here in the backend, in Datomic, we have an API, and this is basically a trusted system, and the peers and services usually can directly call into the database. That's definitely not something that you want to have in the clients. So this is for now an unsolved problem, how you actually do distributed state changes. You would still have to talk back somehow to the serializer, implement some access controlled, application specific API, whatever, to go in there. You don't want just people to be able to send arbitrary transactions into your database. That would be not a good idea. Okay. So Datascript open sources basically the Datalog programming model in Clojure. That made it much more popular, I would say. It also made it accessible as a NPM package. You can just use it from JavaScript. You don't have to worry about Clojure at all. Also in the JVM. I don't think they have Java bindings, but it would be probably easy to write them. It's something that we will probably do for datahike at some point. It provides Datalog mostly to the front end, and later also provided it for the JVM. And there were other projects that were spawned that tried to deliberately do this web after tomorrow thing, which is doing this pattern matching and replicating from Datomic into Datascript. It's a little bit more subtle though, because Datomic and Datascript don't have exactly the same semantics. They have, the schema handling is a little bit different. And I think these projects have struggled to make this like 100% work out. But the biggest problem, I would say, is if I did this, like just use Datascript in a state atom in a client, and you regularly get like new data either from the user or from your backend. Whenever you do this, you have to rerun all the queries of your views. And that's kind of okay if your app is small, but you quickly get to a point where it starts to become laggy and you rerun the queries regularly to update some list view or do some searches against the backend. It starts to feel clunky. And this is a fundamental problem because you eagerly realize the queries whenever you need them, but you're not basically like constantly updating them. You don't have materialized views. And there was a very interesting answer to this. It's called differential data flow from Mozilla. I don't know whether you've heard about this. It's implemented in Rust. So initially they implemented, I think, also the Datomic clone in ClojureScript, which was called initially Datomish, and now, I don't know. Mentat, exactly. Mentat, yeah. Yes, that was the name. So yeah, they have made this very fast in Rust, and they have like a small map filter reduce kind of DSL. I think it's not exactly Datalog, but there is Clojure 3DF, which is basically implementing the Datomic Datalog on top of differential data flow. So you can have materialized views. This is similar to Falco. I have not worked with Falco yet. I don't know whether anybody of you has tried it out. It seems to be like very much similar to the thing that I'm describing for a big part of this talk. But the point is that they do it for exactly the same data log. And I think Falco has like a custom DSL that basically describes what you kind of consume from the streams and how you views, how you subscribe to the backend. I've talked to Nicolas, who is working on this. He's doing his master's thesis at ETH in Zurich. and we want to cooperate with them. So for them, it's important to have also something like Datomic, like the actual database that you can run queries against, and datahike can basically be changed to make their streaming easier and track the same things. And we ideally want to merge this, so you can have materialized views and subscribe to them, and you have also a normal backend database that you can run queries against whenever you want to. Okay. But for me, initially, my opinion was a little bit different. I've shifted for now to I think datahike is much more, or Datalog, the datomic model is much more practically relevant if you immediately build backends, because you can just build it in, you have a good database, and you have all these semantics, and you can start from there. But when I started, basically, I realized that the write operations are an important problem. Whenever you have peer-to-peer systems, what they tend to do is either they are completely read scalable, like BitTorrent, or like peer-to-peer file sharing systems in general. This is kind of a solved problem. But if you want to collectively like share data and mutate it, that's very hard, because you have these kind of conflicts between the ordering of operations, and they can interleave in ways that are unpredictable. And then I basically looked into CRDT. So Nikita wrote in his blog post, and this is like a thing that I don't think is right, so I will just read the quote for you. So for example, a database could provide a strongly consistent event log, and database client synchronization protocol can take advantage of that. Or you might choose eventual consistency, CRDTs, and anti-entropy measures. Anyway, distributed computing is pretty crowded these days. Let's assume we know how to do it well. But I would argue it was and it is crowded, because it's actually, we don't know how to do it well. Otherwise, it would be less crowded. So it's not that easy to solve this. And I've done some research on CRDTs, and I think they are very useful and helpful. But yeah, I will talk about this in a second. But I still think it's hard. And a replicative tries to basically be eventually consistent and solve the whole problem of the system for you, but without Datalog. So it's kind of a different angle at the same problem, but it is aiming for Clojure and Clojure script support. So this is basically the high-level picture. So you would have your app here, and replicative basically abstracts over the whole distributed system for you. So it can talk to durable storage, and I will talk about this a little bit more in a few slides, and also about over the network. So it synchronizes with all other peers, and then it's gossiping basically all the changes in the network. And this is implemented by a set of middlewares, which actually then built the whole replicative thing. So it is implementing these CRDTs from the literature. So I probably should introduce the CRDT. I will not talk about them too much because this talk is about Datalog. I will at the end mention that they are actually part of this. You can recover them in Datalog itself. But CRDTs are basically object-oriented kind of APIs to change an object that has certain semantics. And in this case, for example, in a map, you can assign and delete values of keys. And if they are concurrently, for instance, added, then you might actually want to have a multi-set over all the values that are in there, and you can remove them. But the object semantics are invariant to commutations in the order of the operations that happen. So wherever you are on the network, you will see the same kind of result. It will not conflict, and it will converge. That's the main property. They abstract over the ordering of the events in your distributed system, which is what makes distributed systems hard to reason about in the first place. So this was basically our attempt to work on this. I started on this, I think, 2013 for the first time. Clojure script was very new back then. Like, there was basically almost no tooling. You had to look into emitted JavaScript code in the browser to see like what you were actually doing. It was pretty horrible, but I had an intuition that it's actually going to be successful because it seemed to be pretty good for front-end development. And in the combination with Clojure also seemed to be convincing. So I tried to aim for this, and I also decided to take core async. One can argue about this. We argued last time a little bit about it. I think there are some problems with it, but it makes all the APIs like completely the same. So you can abstract really over the different platforms. Okay, so for the durable I/O, if you actually just want to have a very simple way to store things. This is basically the durable I/O layer. I've called this conserve, which just means to conserve data for kind of obvious reasons. The most important thing that you need when you want to implement a database is you need to be able to reliably store at least single things, not distributed, but you need to be able to go at some place and put something there and be sure that it is there. It's not like asynchronously written, so you need to make sure it's synced to disk or whatever you need to do. You want to have these ACID properties at least on a key value basis. So when I assign a key, I want the value to be there, and I don't want to have concurrency issues and stuff like this. So that's the only thing that it's solving. It's very simple. But the advantage is you can, as long as this is enough for your application, and many small applications don't need a lot, you can just use this and the overhead is very little and you can change the backends without a big kind of problem. The only thing is, like, one can argue about is the core async thing, whether you actually want to do that or not. But yeah, I think it's very flexible in general, and it allowed later on to implement like port replicative extremely easily to different parts. And now it's basically also the backend for datahike, so you can port it more easily to different environments. And this is the second thing for the network. So the idea is, when you have a network, what is the essence of having network connections? You have basically bidirectional wires, and they are not like they're not entangled. So I can always send and I can receive typically over wires. These are separate things. I don't need to model them as one, let's say channel or queue or whatever. That wouldn't make a lot of sense. So the basic essence, I would say, is like, okay, try to use a bidirectional thing. So this was the basic abstraction. And then if you have this as core async, you can just basically intercept the wire at any point. And I will show this here. So basically the core of a peer would do some publish and subscribe things. So it sends things over the wire and messages, but it's not strictly necessary that you have to do it that way. You can also just think of this, you are able to establish a wire and then you can intercept this and implement the logic. The difference to Ring, for example, as a middleware that does almost the same thing, also, but there it's like a call that comes from the outside. So you basically have one remote procedure call that goes through Ring and comes back. Here, this is like an active connection. So you can at any point inject messages into this connection, which is WebSocket in this case, could be anything else. So the different layers are basically able to intercept messages, but also to initiate communication. So in that sense, I would say it's maybe the most flexible thing and the easiest thing to separate concerns over this abstraction. Okay, and then replicative was just basically gluing this together. So just plugging in, as you've seen here, hashing to make sure that you have actually the things that you're fetching are consistent. So you don't want to be somebody to poison your data and send you different things if you have a distributed system, if you think in this very like broad general way, but it's also just a consistency check. So this would be a consistency check. This would fetch basically, if you think about distributed data structures, this fetches all the parts that are referenced somewhere. So it is loading the rest, and then you can basically subscribe to different CRDTs as well. But as I said, like these are details. It's just important that this made it kind of reasonable to take this apart again later. Like in this compose kind of idea, you try to build things from parts that that you can change later and figure out a better way to do it. Okay, and then we have some CRDTs. We stopped so far. We have paused this for now because these are, my opinion, from a practical perspective. My CRDT friends will hate me for this, but I think strong consistency, if it's not expensive to you, it's way better. Yeah, you don't want to default to eventual consistency if you don't have to. So if your system can just behave like datomic is a very good programming model. You just have one sequence of actions. You can always look into it. You can snapshot it. You can compare two versions of the database, ask what happened between them, and do all these things. This is not as easy in CRDT setting anymore because there's concurrency everywhere, basically, or at least you allow this deliberately. then the essence of each CRDT is actually its merge function. So it's able to take two sequence of events or two states of the application and merge them in a way that is consistent. So it's order independent. If you if you send me the same state again, it's idempotent. So it's not changing. It has a few of these properties that you have to come up with if you want to build a distributed system that is robust under failures and so on. But this is not necessary to expose them as a data type in this object-oriented way. So one can argue whether there are better ways, and in the end I will briefly mention this. It's also not easy to compose them. If you plug a CRDT into another CRDT, and then the outer one is changing and the inner one is changing, maybe you want to do this in a very application-specific way, like if you have an item to a to-do list and it's outdated, the one guy might change actually the item and make it updated, the other guy might remove it. The question is, how do you actually want to resolve this? It's the standard CRDT API will not allow you to, will not expose this to you. Well, there will be some default conflict resolution. So either it will be always automatically removed, like the CRDT will just,
depending on the CRDT type, they all have a custom, like default.
Yes.
The resolution strategy.
They abstract it away from you, but in this case, you have to basically manually decide of how this should interact, and that's not part of the formalism. That actually brings back all the problems again. So once you start to nest them in a more complicated way, I would say you start to get these reasoning problems. So one idea that I had with the CRDT researchers that I talked to, actually what you want to do when you build your application and you want to have it, you want to be able to operate in this offline and very decentralized way, you would try to build a CRDT for your whole application. It makes much more sense. Take like parts of it, of the CRDT logic and the ways that you can compose them, and try to build a CRDT for your application right away, which is more complicated, but I'm not sure whether there right now is a good way around this. I will talk about this in the end also briefly. Okay, so finally we can talk a little bit about Datalog, but I'm not sure whether it's still like, do you have questions so far? You seem a little bit, maybe I lost you somewhere. I'm not sure whether it's practically useful for you in the sense that, yeah, in the sense that whether things that you found interesting so far, or any particular things that are helpful, or any things that are
definitely helpful. Yeah, we are basically facing the same problems with linearization of events happening in the board. You know? So it's like, yeah, state management basically.
Right. Yeah. Okay, I will quickly introduce Datalog and then talk a little bit about it more, and then we will finally get to like, okay, to datahike. So Datalog is a subset of Prolog. Who of you knows Prolog? Who has tinkered with logic programming already? A few people? Okay. Logic programming is just the idea you describe what you want, and the thing is basically trying to find a solution to what you want. And if it can find it, it will report it to you. So it's more declarative than functional programming, because in functional programming, you still have an order of things that you can compute, and you can like basically always ask the question, so far, if I evaluate these expressions, what would the result look like? If I give you a bunch of logical constraints, I could ask what subset of these constraints are fulfilled, but there is no order in the computation itself that's visible. The solver is doing it it's more decoupled from what you're actually reasoning about, which can make it also very hard, to be honest. I mean, if you don't get any results, then there's some contradiction somewhere. How do you find it? You cannot step through the program easily. You have to basically deactivate clauses and try to get to a point where you get results and figure out where it's basically failing and so on. It's a little bit of backtracking than like manual backtracking. It sometimes can be not super intuitive, but when it works and when you've learned a little bit of how to use it, it's way easier to manage than, for instance, go into a database and do a map reduce filter kind of MongoDB, I don't know, query thing, which is way more, it's way more about how to do it than what you actually want from the database in this this kind of terminology. So what it's doing is in Datalog specific is similar to SQL in the sense that it is a relational algebra and it guarantees to terminate, so it's not Turing complete. You cannot write arbitrarily complicated programs, which is kind of probably good for the distributed system. It also means you cannot, your distributed system, if you use it for the whole system, cannot do any kind of computation that you might want to do in a distributed system. It's not like the solution for all kinds of distributed computations. Scientific computations that do some solving or simulations might actually not be reasonable to think about them in terms of Datalog, or at least not right away. But the difference to SQL that's very important is you have an implicit joining of variables. So I introduce variables, and I will show this to you in a second. You introduce variables and they will automatically be matched. So you don't have to do this where blah, blah, blah is equal to blah, 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 and basically join the tables and the columns of the tables manually, which is always, SQL tends, it's better than nothing, but it is not very concise in the sense that there is a lot of redundancy. What's also nice about Datalog is recursion is fairly elegant, so you can have recursive graph queries. You can, for instance, ask for all ancestors of somebody who's in the database, which will just recursively basically walk all the parents of the parents of the parents and so on and call itself. It has because it's a programming language, you can also write like clauses that are inference rules, and you can just call them. I will show this to you on the next slide. And I would say in that sense, it's a very well-constrained interface language. So if this is the language that you want to talk to the system, describe what you want, it's high level enough to allow the system enough freedom and to design it in a way that is flexible enough to adapt it to different distributed system environments, like eventual consistency, front-end, back-end, and so on. But at the same time, it's also flexible enough so that you can do any kind of reasoning about data that you want to do normally. So I would say it's, yeah, I mean, you don't have to argue about the success of SQL, I think. Okay, this is maybe a little bit too small. Can you see this? I guess like everybody of you has done something with this, will probably know this, but this is an example query, very simple in a sense. So, but note, as a Clojure developer, you really like this because what is this? This is data. It's not a string. So that's very convenient if you want to build queries with Clojure functions and do it at runtime, which you can parameterize them. Normally you don't have to. The language is made in a way that you can parameterize them directly, but still, it's still data. If you want to like store them in a file or fetch them from somewhere, like they can be part of other data structures. You don't have to reason about them separately. So what we do here is we introduce logic variables that we care for. This will be the result set. I should have printed this, I think, but E will be some value and senior will be some value in the result set, and then you might have multiple tuples of those. So we match here the entity E and say, okay, it should have the name Peter. So this is a relational clause. So these are clauses basically that are matched to our database. We say, okay, we want to, E has an experience A. So this is years of experience, let's say. Just made this up because it's like not really important what it is about. This would be a rule that you can call. Actually, I should have included here that the rules are passed in. But this is an example of how you can call a rule that you would define in similar terms outside of the query. So you can reuse this. So this could be a logical predicate that you can define in any way to figure out that somebody is programming in Clojure. You might have like different ways to access the database, look into job descriptions or whatever, and try to figure that out. And here, basically, you have a logical predicate, and you bind this result of this to this variable. So this will be true and false. And then you can basically add clauses, and this will logically match and just describe what you want. A particularity that the Datalog or Prolog people will not like, and basically one of the professors at UBC was, I think, not exactly convinced that this would be a good implementation, because in Datomic, at least, the ordering is the ordering that you write down in the way that it's matched against the database. So if you want to ground variables, and the same for datascript and datahike, then you have to first ground them to values before you basically match them in arbitrary ways. That's a little subtlety, but on the other hand, it allows you to reason about the performance. I think it could be made better. So hopefully at some point we can have a query engine that actually does the rule planning thing, and then the order doesn't matter, or at least it tries to pick a better default order where this doesn't matter as much.
The engine should take care of optimizing.
Yes. Yeah, it should. It should look into the indices, the same like a SQL query planner does, and figure out, okay, there are possibly so many tuples here that I can match in there, and I try basically to project the strongest constraints first, so that I don't enumerate over half of the database or do something crazy. Yeah, but it works relatively well if you know what you're doing, like practically speaking. Okay, this is not too big. So this is basically the programming language, and this is how you can describe it. It should feel somewhat natural. One thing that's also nice, you can, because this runs in your process, you can call arbitrary Java or Clojure functions in your query engine. It's not unsafe for the database. You cannot block the transactor. It's just your query gets slower, but it's very powerful if you, for instance, want to join with another database outside of it and do this inside of, I mean, it could easily also go wrong. At that point, you can make like arbitrarily bloated up searches, but yeah, but you can at least try, and in some cases, it's actually very concise. So, and this is basically how I've taken this. There is an unofficial guide to the datomic internals from Nikita as well, who has written datascript. So this is basically, there are 3 indices. That's like a very good idea, I would say. That's like entity, attribute, value, time. This is the one that you see here. So here's entity is just an integer number in datomic. You have some attribute, which is a keyword in Clojure syntax. And here you have some values that are assigned. And note that their values are not, well, it's like in one index. Like their name and the year would be different columns, but the indices are actually flat over the whole thing. So you can just pattern match the full index, but you don't need to create a new index for each table or something like this, or column of a table. This is basically kind of sufficient, but you have 3 to be able to match in different orders, with whether you know the entity and the attribute and want to know the value, or if you know the attribute and the entity, but you want to know the value, or maybe you know the attribute and the value and you want to know the entity. These are different ways basically to search over the index and get this out of there. So this is why you have 3 times the index. It's kind of an implementation detail, but it makes, if you think about all the things that you have to learn about SQL tables and how to deal with tables and so on, manage tables, you need a database administrator to manage with tables. It's kind of nice that you can avoid this. Okay. The good idea then is, because it's a persistent data structure, you reference a snapshot of these indices, your query engine runs locally. And the snapshot is basically for free. So just ask the transactor, what's the current snapshot? It sends you a small data structure. You have to locally maybe fetch some of the index fragments if you don't have them, and that's it. So it's kind of a very simple design. If you think about like multi-version concurrency control in database, you can probably read a bunch of papers and figure out how to implement this. I think it's amazingly simple as an idea, and still reasonable to do. It's actually, yeah. Okay, Datomic needs a schema for each relation. So you cannot insert data if you don't have a schema declaration. But attributes all attributes are optional. That's part of the Clojure programming model, that you don't have maybe types. So you say that the language itself is not deciding this. You basically have a secondary system like spec or something like this that would decide for you, or wait, you describe your information model and say this information has to have this shape, but it's not. The computation tries to be resilient because typically everything is sparse. All the information is sparse and you never know whether things will be really available. So you try to avoid to bake this too much into your language. That's at least the arguments from Witschicki about not trying to build this indirectly. Yeah. A really cool thing is you can join over several databases. I don't know whether you have realize this, but you can have a database in memory, you can have a database on DynamoDB, and you can have a database in your PostgreSQL backend, and you can all take them in the same query and then match different clauses against them. That's a pretty powerful thing. Okay. It's auditable. It has this very nice history feature, which is very convenient. Sometimes it's also useful for application logic, but people have argued that it's better to record like business time in your database and don't use these features to directly encode time, because it's the time of when the database was run and not necessarily the time that people recorded on their devices. Yeah. And you can access, that's the cool thing, because they're persistent data structures, you can just run MapReduce queries or whatever you want on the raw index data as well. If you want to do some batch processing while the system is running, just go there, grab the index, and do whatever you want to do with it, and you have access to the data. It's not like only accessible through this high-level SQL thing, but you can easily get it. Okay, so what is Datahike then? Datahike basically is just, a year ago, basically, I thought, like, okay, this is possible. I know that these parts are there. I looked at the hitchhiker tree and so on. It must be possible. Datascript uses this sorted index internally. It's very simple. You just have 3 indices. It should not take me longer than like a few days to hack this together. And actually, it worked. So I could use the hitchhiker tree, which is a durable tree index data structure. That is was, I think, announced 1.5 or 2 years ago. And the in-memory query engine of Datascript. And that's basically what Datahike is. So obviously, I'm very thankful. It's very cool that we have Datascript, because otherwise this wouldn't have been possible. So this is, like I mentioned, the in-memory implementation of Datalog, and it's very mature. So Datahike itself might not be, if this would be a new project, I would have like argue or convince or reason about, is this actually stable? Would you want to use this? But I don't have like a very bad, I recommend to use people to use Datahike and try it out, because Datascript is actually very mature. And it's just this small interface gluing part to replace the collection. So you have a huge test set, and all this is fairly tested. So despite the fact that Datahike is fairly young, and it's just 0.2 beta since last week, so we have rebased it on a recent Datascript version. So it now supports also not and or clauses, which were not supported before Datascript. Datascript itself is a faster in-memory query engine than Datomic. I think Nikita is pretty proud of this. It supports the full DSL, or almost all of it, but it has an opt-in schema. It's also something that I wanted to ask you. Do you actually want to have a schema, or do you not want to have a schema? Or how would you like the database to decide this for you? It's not strictly necessary, but it becomes hard if you later want to introduce a schema and your database has all kinds of mess in it to sort it out. It's kind of, yeah, the convention of what to store. But it's just a local single process implementation. The hitchhiker tree, on the other hand, is like a fractal tree. It's a mixture of a pendlog and B+ tree. I have written a blog post for Datopia for this. So you can just check the time, by the way. Okay. Almost an hour, I don't know. Okay. Who of you knows a B+ tree? Heard of it?
There's also a talk, very interesting.
Yeah. Yeah, by David Greenberg, exactly. You can read up about it, but it's kind of a nice, good combination of an append log, which is very efficient to write, and a B+ tree, which is a standard database optimal index data structure. Okay, I will not go into detail. Okay, this is how it looks like. It's just nice here, and you also see this in this talk, that you have the right append logs here, so you can walk into the tree, but you can always leave hitchhiking elements there, so you don't have to go all in to write an element into the root nodes. You can just plug them into any spot that is free, and it will only like transport them downwards in write operations when this becomes too full. So it's bounded, and that ensures that it still logarithmically scales and stays balanced. Okay, then there was a simple benchmark. It's maybe not too important, just that we haven't screwed up, so we are not slower a lot. That's maybe also. So yeah, obviously these persistent data structures, hitchhiker tree is easy to replicate. If you would be interested in this, we can talk about this. And you can basically use any DHT system. You can use a system like DynamoDB on the back end. You could use any key value store basically to store all the index fragments because they are immutable. You just need to be able to do reference, and then I just need to tell you about the root. So I just sent you a message, there's a new root, and then you can basically, that's how you can easily replicate the index without a lot of coordination. Okay, so we have now, by gluing this together, we have something like SQLite. So it's just in process. You load it, you have a local database, small, it has some caching and so on, so it's not too slow. It's actually comparable to datomic in simple benchmarks. We have some prototype projects that we quickly mention. We can replicate in a similar way with the dat project, which is a file replication scheme in JavaScript. We have a foundation DB index implementation, which is not persistent. But if you just append to an index, imagine you write into a log, or you want to just record a lot of events and don't remove them, then it's kind of okay in a sense. And then it would be nice because the query engine can ask this very fast thing as well, and your business data at the same time, that you have different kinds of semantics for the kind of data that you want to have. So that's really where we want to go, is have this composable database stack. You can have a Redis in memory thing. That was what David Greenberg also mentioned in his talk. He was very proud about this. He has like a counting garbage collector implemented in Lua in the Redis DSL, which is pretty crazy. So it's actually pretty optimal, I guess, in some performance sense. I haven't activated it yet because I haven't needed like the Redis in memory speed so far. You need to be able to obviously keep all your database in memory then, but in-memory databases are really hot. So SAP is doing all their stuff, like they're close to Heidelberg, like HANA is the future and so on. Yeah. Okay, you can replace, as I said, like the key value storage, the materialized view. This is what we are thinking about. We also ideally would like to have a Node.js version. It takes a little bit longer than anticipated. Okay, so now in this case, we have basically addressed the full system that we would like to address if we want to actually think about Datalog for systems programming language. The only thing that is missing is, well, I can just say it, is eventual consistency. We don't have that yet. And we don't have, well, right there. Yeah. So one idea is, I guess, yeah. So one idea that we had 1.5 years ago, a friend of mine and me, is actually Datomic is almost the perfect blockchain. It's ridiculous, the whole blockchain hype, but in some sense, it's like, what are you all doing? I mean, they're doing these ledgers and this very complicated state machine things that they replicate and try to show, but actually it's very simple. I mean, just use an immutable database, and it's kind of the thing that you want to have, and people want to store their data in there. They don't want to run like smart contracts, JavaScript programs for shit tons of money. That's very expensive. I mean, if you look at the gas price of Ethereum or something like this, it doesn't seem to make sense for normal application developers to use this practically. I mean, unless you have a very, I don't know, it's very difficult to construct reasonable use cases that fit into this the idea. But I think the blockchain space has one idea kind of right, or at least at some point I thought like, well, maybe they are not totally wrong about this. So you have multiple parties nowadays, and we live in the, we can say, do I have this here? Oh, okay, I talk about this here. So let me follow my slides quickly. So what is if we want to coordinate between different parties? Like if you have different companies that actually want to build like shared products, and the database is always basically the central point of control. So it's a point where you can argue whether who owns the database, who runs it, who decides about it. It's kind of a political issue in some sense, how to deal with it. So can we actually try to generalize it to this setting? As I said, like it's a good starting point. It's already auditable, which is kind of the first step to a blockchain. It's like, okay, we have this chain of immutable blocks that nobody can change, and that we can later on like check that everything is correct. But what we also want to do is kind of high volume in some sense. We want to be able to write like normal amounts of business data into it, and we want to be able to ask easily for data. So the problem is we are not permissionless. That's like the attribute of the blockchain that is not working. You cannot just set your database on the internet and open your transactor and let anybody write what they want. So that's what I mean with permissionless. You have a system where people can just that people can access without somebody explicitly guarding it and deciding who can do what. So I think this high counterparty risk point in that order might not make sense. So the point is you have a the idea is if you want to basically try to find things like supply chain management or parts of the infrastructure that you want to share and that you don't want to immediately get privatized, because that's what SAP and what these companies are doing. They basically get into the space, they place their databases there and the whole infrastructure, and then you are subscribed to their model and you don't get out of that. So if you want to try to build something that goes beyond that, then you would like to implement a system that I've taken like the term data commons in a sense. Like you try to establish a common good, even if it's just between two parties, and you try to regulate the access to it to mitigate counterparty risk, so that the other party is not basically trying to screw you over. And I think the interesting thing about this is not necessarily directly to have a solution, but I think also despite the fact of the blockchain hype and the pushback and so on, this is a new design space. There are new ideas that you can come up with. You can think about new rules and systems that people can interact with that will not go away. It might be like a little bit of a backlash right now and so on, but I think in the future people will come up with interesting ideas of rules of how to do this. So how do we turn the system like datahike into a permissionless system? First of all, we have to distribute the transactor, so nobody has physical control of it. And then we need to figure out logical rules to control the access to the database, of how to write to it. Reading basically is no problem because it's already like, we can distribute it, it's immutable. We can ensure that it's consistent by having Merkle hashes. That is not really hard. It was like already one of the replicative libraries. Hash basically does this for you. So the first step is we can use, and that's what we've done. We have a prototype that's using Tendermint, which is a blockchain implemented in. It's basically a framework to implement blockchains, implemented in Go. So it's just an RPC API, and we have made this more convenient. So you can just use this. This is just a Clojure library. You don't have to care about anything about this at all. If you want to tinker with a blockchain and build your own, this is basically just a repository. You can easily implement a few of these hooks, and then you spawn the system, run it, and you have basically your own blockchain system. We have done a lot of literature surveys. People can argue about this is like proof of stake, proof of work. I don't know. In some sense, this is like from the 1980s, and this is called Hugh stamp replication. I want to look up the replication, the reference of the paper. It's really old, the practical Byzantine fault tolerance. Tendermint is adapting this. They have like a paper where they change it a little bit, but it's well established. It's understood that this is a safe Byzantine fault tolerant algorithm. You can just use it, and it's I think it's a fairly solid thing to do. It's not too speculative. You don't have to innovate necessarily in the space if it's not relevant for your use case. And then what we did is basically we use Datalog itself, and that's kind of funny and kind of I would say pretty cool, because you can use Datalog to actually query whether transactions are safe for your database. So you can write rules and you can add them to your schema, and these rules will tell whether you accept the transaction or not. And in that sense, you can easily have like balanced accounts, positive accounts. That's very easy. I mean, how would you write a query against your database whether this is fulfilled? We have seen the clauses. It's kind of easy. You match all the parties that are part of the transaction, and you look at whether it's zero sum. So you can just do a few of these clauses, and that's it. So we have an implementation of this that also runs with datomic, by the way. So ideally, again, it should be a library. It should be reusable, because it might not be the thing that in the end is really important. And that's really nice in Clojure, that you can factorize things and can reuse them, and it doesn't change. Like my code from 2011 still runs today. It's still working.
So this is a library on top of datahike.
This is a library, yeah, on top of datomic. It's just using. We haven't released it yet, so that's part of, yeah, that's part of my fault because I'm so busy with my PhD things.
Don't worry.
No, but yeah, my friend is angry because it's so cool. Like we really have to. I mean, that's also one reason why I'm here. Like basically, actually getting this blockchain idea out and just being able to run something like this in a shared environment is a pretty useful and important thing. And it's much more reasonable than talking about ledgers and all these other things. Just trying to share a database and figure out some rules to how to manage this together would already be like a big step forward in some sense. And you can try to design a system in a very technical, reasonable way. Like if you think about how do you run a service in Amazon, you have quality of service, you pay for this, you can measure this, and you can reward parties like the transactors that run your system. You can reward them for the quality of service that they provide, and you have some fees to put things into the database. But actually, querying is practically almost free because we can just replicate the immutable indices. So in that sense, it fits. It makes a lot of sense. It's still not directly easy to say this is a product I can sell this and then we'll be able to make directly revenue. But technically, it makes a lot of sense to build something like that. So yeah, this was basically my point. Okay, it seems these parts and Datalog makes a lot of sense because you can go there and you can do these things. And yeah, okay. So I will wrap up and then you can ask questions or leave. So yeah, this is basically then the big picture. You can have your whatever client or server, you can talk to different datahike instances. You could have like a Datopia instance, which is, let's say, a public, it could be a ledger actually. It could be something that has just like DBpedia on it, for example, and you can access it and there are some ways to update it from the outside. So yeah, you can basically run this infrastructure, you can join this infrastructure as well. Okay, so we can implement CRDTs in Datalog. I will not talk about this, you can ask me later. But finally, this is actually a CRDT researcher came to me and said, like, I talked about the Datalog database and said, like, yeah, I've actually formalized CRDTs in Datalog. So now it looks like we can use them. These are just query rules. I can show you. You can just implement them in standard datomic. Okay, and probabilistic programming, I haven't talked about this. I think it's also kind of interesting that you can add a few probabilities to your database, to all these data points that you have, and to the query clauses. And there's actually a professor at UBC who is kind of expert in this. So we can you can also do probabilistic reasoning in a database. So I think machine learning and AI kind of applications, a big part of it makes sense to just outsource it to the database because the data is already there, and for simple things it should definitely work. I mean, if you want to recognize cats, maybe that's not the right place to do it. Depends, but yeah. Okay, these are people that I've worked with or that I'm really grateful for their work, and that's it. Yes.
Quick question. So you mentioned wanting to have datahike working with Node. How would you imagine the mechanism for querying within JavaScript? Would you take a similar approach to the the datascript implementation, where they are strings, or do you see yourself taking like a different approach?
Oh, I see. I have not thought about this yet. I would have thought to just basically take the datascript approach and provide a way to have a durable index, because it seems that this probably is already established. But if you have some experience and would say that this is inconvenient, you would rather have like JSON or something like this to describe queries. I don't know whether this is what you have in mind or like.
Not sure, but I've been kind of experimenting with using datascript from native JS and found, building up queries a bit trickier just without the
Okay, interesting. I haven't
data structures.
done that yet. Yeah, I think the Clojure script ecosystem is pretty interesting. So there are different ways. I mean, one way would be to take datahike, the graal VM, and just compile it into a binary and link node against it. That would be like the easy way. The other way is to lift core async into the query engine and try to make the query engine basically composable with async IO, and then expose that, which is much more lightweight, I think, and also would run the browser against IndexedDB, and you can do more things. That's what we actually want to do. So the hitchhiker tree already runs on Clojure script, but we haven't done the query engine part yet. So it's just the time, I would say. Don't think it's super hard.
Great, thanks.
Yeah.
Curious about the similarities between datomic and datahike and like RDF and triple stores. It seems like there's a lot of analogies between.
Yeah, I think Rishiki also referenced like RDF quite a few times. I think also in the speculation talk. I'm not sure whether it was this one, but yeah, I think the RDF community was very good at thinking about information models that are like shared in a bigger space, and you don't get these schema clashes and all the problems that you get if you do this ad hoc. So I think it's just a way to make RDF and these technologies much more accessible for functional programmers. Like I would say it's just done right with the right kind of technology, but the information model is very much the same. Like even the keywords should be namespaced, which is an RDF that you try to have your domain names in front of attributes and things like this.
I work with some coworkers who develop ontologies. I wonder about, if you're interested in sort of this JSON LD linked data kind of idea, then having a shared set of attributes in your database that you can share across platforms and systems and still be talking about the same things could be a powerful idea.
Yeah, I mean, ideally you would. Yeah, I think. I mean, one benefit of the fact that you can condition your query engine on the database, like the clauses, is that different databases might have different schemas and it would still work because the query engine can distinguish between the different databases that you're joining against. So it's not confused by that fact. So basically they're all prefixed by the instance of the database that you join against. But in general, I think that's the idea that also is behind Datomic, and it's like also the long-term vision of this, because Clojure has more and more got like namespace keywords. Spec is completely namespaced syntax, so we try to move away from these conflicts between different applications.
I think the hack could be if you have like a system where user name and password means something, and another system, they are basically the same but going different ways. We don't share databases, so you could have like a datomic transformation. So when you run the query, you kind of like read, okay, this means this to me, and you transform the data so that the application understands and receives the right fields.
I'm not completely convinced that the ontologies really solve things, because actually getting people to agree on the which URI to use for what term is sort of a social problem that people get sort of territorial about which ontology to buy into.
We would, I mean, in the e-commerce sphere, basically, this is a big problem, right? I mean, not only here, but we were talking a lot about, my user has a name and password, but in this other system needs first name or ESV, and how to reconcile it. We ended up postponing the decision of what to do with that.
Yeah. So is
datahike supposedly eventually going to be equivalent to datomic, like an open source version of it?
So I think that's a very valid question. So it's definitely not just a simple, we don't plan to just copy datomic. But if you think these are very good ideas and you try to recover them, you stay close to them. And right now, actually, the API of datahike is matching the datomic API directly, simply for the fact because this makes it most easy for people to try it out. And there's no big reason to diverge from this so far. I think yeah. I think the goal is more to have like this whole system perspective and not just provide a very nice service for AWS and a few backend things. So Datomic is kind of more focused on people who really need, who basically a target group that most likely needs a database like this. It's less for people who just want to build a small project. I mean, they have a free version and they try to appeal to that, but I would say the way that it is conceptualized in a way that's developed is very much with a focus on this AWS scalable thing. I think ideally you can take this apart and do crazy things with it because it's fairly small code base. Even datascript is not super large. I would say it's relatively well written. The hitchhiker tree, we try to refactor it at the moment. It was not super accessible, I think. On the other hand, you probably don't have to change that, I would say. I hope so. So I have a much more composable vision in mind, and I think it's more of a starting point. But I think if we want to be successful and also what the Clojure community wants, it's clear that you want to implement a subset of Datomic as an open source implementation. I think it makes little sense not to do it if you do something so similar. And I have the impression also that this helps Datomic because people have these pain points of thinking whether they should get a commercial database and they don't want to commit to that. But if you have an open source version of it that actually is maybe not as powerful and not as mature, but you can at any point move to it, then there's less, you have to worry less about moving into the Datomic direction because you can always port away from it and don't have to restart completely. So right now I think it's kind of also beneficial. I'm not sure. I think if we go too much into like directly doing the same thing, how Cognitect would react and how this would be. So far,
Open source, right? I mean,
yeah. So far, I think they don't care, and I think also that's appropriate because
I'm
data.
waiting for the day when the open source is completely. I think that's a huge point for a lot of people.
Yeah.
Wanting to have their data locked in this proprietary technology.
I would appreciate it as well, to be honest, despite the fact that I'm now committed to this. But I think actually that would be pluggable, so you could reuse also the parts again. I mean, it would not be a big loss in some sense. I don't understand honestly why they have done it that way. I'm not sure. I think it was not optimal. Also, if they want to be, I mean, I would have at least have had like a basic open source version and then done something as a service on AWS. I wouldn't have gone this all-in proprietary thing. It felt odd.
You see, even the Rebel thing is open source, but the source is closed. And yeah, it's very way. I don't know. Just the language is fully open, but not really open to change.
I had a question about the Datopia
Yeah.
stuff. I'm not sure if you touched on this, but are you assuming that all the data that's stored in that part of the system is public data, or is there any sort of like authentication, authorization layer in there?
So I've mostly talked about write access, which means everybody can read. You can encrypt it. It's not obvious. I mean, you can just use public-private key encryption schemes and try to do that. And I think they're actually that's the part where the crypto space, the blockchain space, has some interesting ideas, like doing this collective key sharing things, and then you can recover parts of it and so on. I mean, there are some interesting technological contributions and work. There's some interesting work in this direction. I think we have to support it, but I think it's not the the main benefit. The idea is rather to be able to share something, at least between some parties that might then run the peers together. Maybe it's not public access, so not everybody can read the database. You can definitely encrypt it to decrease this, but
Would it be feasible to just add a layer in front of it that would handle?
I think you would have to encrypt probably the index, and then replicate this, and then it's not clear on what granularity you would do that, whether per schema attributes maybe that would be possible, but it probably will hurt the query performance a bit. On the other hand, this is maybe not a super high throughput system, so it would not be a problem. It's definitely something that we thought about, and I think people will continuously ask this. I just think the things that we need to get right first are kind of getting a good descriptive language of how to manage the access to the system, and just try to show that this is feasible, and demonstrate this and solve this problem afterwards. I mean, we have also thought about censorship, which is something that the blockchain community hates, but you can at least, I mean, people will put stupid things in databases like this if they can attack it by that way, like child pornography or whatever. So you can always like at least blacklist and share a blacklist where people would not share these elements, and you can still have we have thought about this, but you can still keep the hash consistent. So maybe you cannot read the part of it, but you would still be able to check the integrity of the rest. And I think a little bit after we discussed this, also the Ethereum guys had some idea about this. But it's not the most important thing. Like I would rather really, I mean, technically it's very interesting and you can totally go nuts in this direction. But it's a question like, what is the value proposition? What are the use cases? And how do you actually make this applied? I think there are some, but they are not fully clear yet of how to do that.
Awesome.
Okay.
Thank you very much. It was great.
It was a little bit too long, I think.